This is kind of a weird looking deal. The roof of a house is at a 20-degree angle. An 8-foot solar panel is to be mounted on the roof and should be angled 38 degrees relative to the horizontal for optimal results. So, how long in feet does the vertical support holding up of the back of the panel need to be? So, that distance right there is what it's asking for, the vertical support holding up the panel. No, this is not an area problem. This is a word problem. So there's two things today, area problems and word problems. This would be the word problem. So, that's 8. This is 8. How about this? And I'm going to redraw this triangle because there's too much going on the page. This is what we're looking for. This is 8. I need some angles in there, though. Well, it's 38 to the horizontal, though.
58.
58? Well, it's 38 the whole way, and it's 20 this much. So what's left? What's the little bitty slice in there? 18. So you got to look at the picture. You can't just start randomly adding numbers together. Because 38 is the full angle, but 20 is up to the roof line. So what's left over is 18. So we're maybe headed toward law of sines, because sine of 18 over x. The trouble is I don't have another pair yet. Let's look at this picture. Look at that triangle. What can I learn by looking at that triangle? That top angle would be 90 minus 38. Yeah. So, wait, not 72, because I need to do 90 minus 38. So, 52. So let's look at that triangle. Let's just pull that triangle out. So we know this full angle is 38, and that's a right angle. So it's 90 minus 38 for the top angle, which is the same angle as this one right there, 52. I still don't have an angle side pair, right? I want to use sine of 18 over x, but I need an angle side pair. How about who's across from 8? How can I figure out that angle? Yeah, so 180 minus 18 minus 52 is 110. Sine of 110 over 8. That's the kind of trickery that we need to be able to do. Okay, this is enough work to show. If you want to show more, you certainly can. I'd probably show one more step, the cross multiplying. So 8 sine 18 divided by sine 110. 2.63. There it is, answer choice D. Angles. Lots of triangles within triangles. Let's do another one similar to that. Number 10. A 127-foot tower is located on a hill. A guy wire is to be attached to the top of the tower, anchored at a point 64 feet downhill from the base of the tower. The guy wire is 175 feet long. Find the angle the tower makes with the hill. So I think the tower and the hill would be that angle right there. So it might be helpful to just redraw the triangle without all the extra stuff on there. And there's the angle I'm looking for. I'll call it A, just because it doesn't have a name. So what law would be helpful here? Cosines, because I definitely do not have any angle side pairs because I don't have any angles. Or it's side, 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 so that makes it law of cosines. So I'm looking for angle A, so I know I'll have cosine of angle A in the problem. So which of the sides goes? Yeah, I don't even know how to ask it. You're already answering it. 175 is across from angle A in the picture, so 175 needs to be across from angle A in the equation. I'm going to press pause and let you try your algebra skills on that, because that is what people mess up.
It's 33.
So angle A is 129, and I'm not wrong, but I don't think that's what this question, I think it asked the wrong question.
The wire.
I think maybe it wants the angle the wire makes with the hill. So that would mean this angle. So it's the same process, it's just 127 squared equals 64 squared plus 175 squared. Does that give us the right answer? Times cosine of B. So this problem was worded wrong. 127 squared minus 64 squared. But by doing it wrong, we actually got to do it twice, so we got more practice. That is trying to justify it after the fact. Inverse cosine of that, 33.9, which is answer choice D. So yeah, I bet that's what the question meant to ask. But again, that's the hardest algebra one, is solving for an angle out of the law of cosines. So having to do it twice is more helpful, right? Let's look at 13, because now at 13, what makes 13 different than all the previous ones? There's no picture. So now we need to be able to draw a picture based on a paragraph worth of information here. To estimate the height of a building, two students find the angle of elevation from a point at ground level down the street from the building to the top of the building to be 39 degrees. Okay, that's a lot of words. Let's make our ground just the line between problems. So somewhere over here, they're on the ground, they look up at the building, and when you look up, that's the angle of elevation. So that is 39 degrees. So we're kind of discounting the fact that the person is like 5 feet tall. Mm-hmm. So it's like an ant is on the ground, or the person like got all the way on the ground and then looked up. Whatever. We're not worried about the height of the person. From a point that is 300 feet closer to the building. So not 300 feet from the building, but 300 feet closer to the building. The angle of elevation. This is why we're working this problem. Angle of elevation. So that means as we look up at the top of the building, it should be more than 39, is 50 degrees. If we assume that the street is level and the building is vertical, otherwise this problem would be a mess, estimate the height of the building. Okay. Well, I see two triangles in this picture. You might see three triangles, but I think we better just see two triangles. Right? There's one on the right. That's the one we need to solve, or we want to solve, maybe I should say, because that's the one that has h in it. But all we have, there is a right angle, but we don't have any side links, so we don't really know much about that triangle. The triangle on the left, it doesn't have what we like. H isn't in there, but it does have more stuff. So I think we can solve the left triangle and then use this side, since it's a shared side. Let's call it x. If we can find x, then we can use that to find h. Questions?
No, that angle should be 130, and I think the one right.
Yep, that should be 130.
Since it's 50 and 90, that the
Top one would be 40. Yep. So we're using some of our geometry from long ago here. And I bet we could even find this angle if we need it.
That'd be 50.
Wouldn't that be 50?
Uh-oh, what'd I do?
Because
That'd be 50, not 40.
This?
Yeah, equals 180.
Well,
Right?
180.
Yeah, 50 plus 40 is 90. Plus 90 is 180.
But 30 plus 40 is 170.
Okay, let's just look at that triangle. Look at that triangle only. I'll even cover up the other one. If that's 50, that's got to be 40.
Okay.
So I can still find this missing angle up here, because that's 180 minus these two. 11. Okay, so I got all the angles settled. And I would like to find this side length. Are you clear why we want to find that side length?
Yes, because it's on both.
Right, it's in the triangle that we want. Let's use some colors here. We would like to solve the orange triangle because that has h in it. But I can't solve the orange triangle without some extra information. So let's solve the green triangle first. But that side x is in both. So that side x is kind of the side that links them together. All right, we go in sines or cosines here. In fact, I could just cover that up. That's the only triangle I care about right now. Why sines?
It has two things.
I got a pair, 11 and 300. So sine 11 over 300 equals, which,
39 over x.
sine 39 over x. So I definitely want to use the x. I mean, I could find this, but I don't really want that. I want the x. Sine 39 over x. So x sine 11 equals 300 sine 39. That would be a step you don't have to show. Okay, that's not one of my answer choices. That's because that's not what I'm looking for, right? So I know what x is. It is the hypotenuse of the orange triangle. So now I kind of shift my sights to the orange triangle here.
90 and then 15x or h.
We can do law of sines again because we have a pair now. Sine of 90 over that 989 that we just found equals sine of 50 over h. press pause and let you do the calculator on that. And you get 757.96, but about 758. Let's do the start of 15 and the start of 16. So 15, two cables of length 300 and 270 extend from the top of a vertical television antenna. Vertical television antenna to the level ground on opposite sides of the antenna. Okay, so one length is 300, one length is a little bit less than that, 270. The longer cable makes an angle of 48 degrees with the ground. Find the acute angle that the shorter cable makes with the ground. So that would be, this angle is what we're looking for. Thoughts on what we could do with this?
Sine.
Put 40.
If the triangle is, you can use 90 sine 300 or 90 with, and then do sine 48 x, you get that, and you can do it the other way, and then use second sine, the inverse of sine, and get that angle.
Okay, so there's kind of two ways to go here. We could find that, work this as two separate triangles, like we did that last one. So find the height, and then use that, and then jump to the other triangle. But I think there's an even better way. What if we ignore that antenna post in the middle, and we just go straight across like that, because this is a triangle. So let's go sine 48. I'm sort of cutting out the middleman here. Over 270 equals sine of A, I can call it, over 300. And so, again, we're ignoring that height that we drew in the middle there. I mean, it's still part of the problem. It's the actual television antenna. But we still have a triangle without it. So 300 sine 48 divided by 270. Uh-oh, what do I do with 0.825? Inverse sine that. 55.6. So that would be B.
Can you always do that?
So can you always, when you say that, what do you?
Like, skip middle man.
Well, we could on that one, yes, but on that previous one we did, I don't think there was a way to skip the middleman because we didn't have, like if we tried to draw, like if we looked at this big triangle here, on that one, we have H, or we're looking for H, we have 39, but we didn't have a full length anywhere else. So that's what prevented us from looking at the big triangle on number 13. So you could draw it and you could write some ratios, but you would never have enough information to get that side H. As opposed to this one, when we draw the triangle, it's like, oh, wait a minute, we got what we need to use law of sines. So that's the trick with word problems, or not really word problems, the trick with these multiple triangles. Sometimes it helps to go one piece at a time. Sometimes it helps to just zoom out and say, wait a minute, I can just use the big triangle and find what I need. When you get to part B of this question, what is the distance between the cables at ground level? Oh, wait a minute, I think we could do, Do you want to separate and do two small triangles, or can we just go big triangle for question B? What do we need? I agree with you, but there's one more thing we need to use the big triangle. The last angle. We need that top angle and like the full angle. Is there a way we could get that angle? Yeah, 180 minus the other two.
Is that just like a badly written problem? Is it supposed to be like that?
No, we wrote the other one that forced you to use separate triangles. Here, you could use separate triangles and then add these two together and you'd get the same thing. But the smarter way to go would be just use the big triangle. Whoops. 180 minus 48 minus 55.6. So that top angle is, the full angle is 76.339. And then we can set that equal to either of the other two, but probably best to use the easier one, sine 48 over 270. And I'll leave that alone. You can finish the rest of that. I want to set up number 16. A large park in the shape of a parallelogram. Has diagonal paths that meet at a 60-degree angle. Well, there's 4 angles in there, but the 2 smaller ones would be 60. I think back to geometry here. What are the other ones going to be? Geometry experts. 120. I assume we'll need that at some point. The diagonals are 12 and 20 kilometers long. Well, I think because I drew it so exaggerated, I think it's easy to see which is the short diagonal and which is the long diagonal. So 12 is the short one, so there's 12 the whole way. 20 would be the long one. I don't know that it really matters. Even if you labeled them wrong, you'd still get the right answer. Yeah. So let's be careful here. So if that whole thing is 20, then that's 10. If the whole green is 12, then that piece is 6. Find the perimeter of the park. So I need to find this length and this length, and then take 2 of them, right? 2 of each of them. So let's take this triangle and pull it out here. So x, 10, 6, and 60. Is this triangle. So what can I do to find x? Law of cosines. X squared equals 10 squared plus 6 squared minus 2, 10, 6 cosine of 60. And then I'll do the same thing. Kind of pressed for time. I can do the same thing with this bottom triangle. And I'll have y squared equals 10 squared plus 6 squared minus 2, 10, 6 cosine of 120. And then the perimeter would be 2 x's and 2 y's. there's another way to do that or not. There might be, but that's the way I saw the problem. All right, so we'll stop there. But we did a bunch together. Again, do tomorrow's worksheet, or do Thursday, worksheet 1, 2, and 3. Worksheet 4 is not that you can't do it, it's just that we didn't have enough days to assign it. So if you want to practice or you want to work some of those, I'll tell you this, the test has some problems, word problems that look really similar to those. So the review is very, very similar to the test.
Can you show us the example of the test so we can,
Show you the test?
Yeah.
I could show you what
on the test.
some examples?
I can show you what the test looks like. It looks like this.
Hey.
That's the review. That's not the test, but it looks really similar. In fact, I'll just tell you that some of the pictures are the same. Change the numbers. Make sure you know what you're doing, but some of the pictures are the same. So I leave it up to you to do it if you need to do it. If not, do. But it would be helpful. So leave it at that, and you can make up your mind as to what you need to do.